Hi, I'm Rosemary. I'm going to do 4 live demos today. I guess that's the best introduction that I can give, but there's a reason why I wanted to do it. We talk a lot about developer platforms, and most of the time when you hear about a developer platform these days, or internal developer platform, we think about going from an idea to production along a golden path, right? You want to offer the most optimized, efficient way for your developers to get to production really quickly. And that's pretty awesome, except then you become really aware of the reality of what happens. You define a platform as your infrastructure to start, maybe, and then you have a bunch of stuff that you put in your applications, because DevOps, that's what happened. And so a lot of folks that I've talked to have said, oh, you know, Rosemary, this is like me shifting left. Everything goes to the developer. And it becomes very clear that a developer needs a better way to get to infrastructure or platform components, so you find an interface for a development team to get to your platform. And over time, what you do is you shift stuff down. I think I like this term a lot more than shifting left, shifting right, whatever you want to call it, but shifting stuff down into platform becomes more and more of a reality. You start taking some of the functions of what an application considers as a custom function, and you move them into platform, something like dashboards, secrets, authentication, authorization, telemetry, CI/CD GitOps, and stateful infrastructure. But, you know, really at the end of the day, it doesn't matter what's in the platform, because everything's a platform now. The point is, there's a platform contract, so it doesn't really matter what's in the platform. We consider a platform contract self-service, on-demand, quick to start, and extensible, right? These are the 4 characteristics that you're looking for. Funny enough, these are 4 characteristics that we talked about in cloud computing when it first started to become a big trend. And then you think to yourself, okay, we have to have a better platform interface. What is that platform interface? Most people choose from sort of 4 options: Terraform, programming language of some kind, GitOps, or a UI CLI that you've built yourself. There's a lot of nuance to this, and this ends up being about a 4-day or 4-week debate with your teams. I'm sorry. And so you actually realize that it's a spectrum. As a team, you're never going to do one or the other. It will often be a combination of all of these. And you realize that your platform interface goes from a lower level interface that offers a lot of customization per developer team to a higher level interface that offers standardization, right? So let's say 80% of your use cases in your development teams will fit into this UI CLI workflow that you've invested in as a platform interface. And then others decide they don't want to learn Terraform, but they have to use it anyway because they have a very unique kind of deployment. And so it's a spectrum. The funny thing is that I've worked in all of these interfaces, and I've been building developer platforms for a really, really long time. In private cloud, we had a developer platform that had a service catalog that a developer could go in and click and get a virtual machine and have their application deployed on it. Was it magical? No. Despite the fact that it was a great developer platform for what it was pretty complicated. And I realized that it wasn't the matter of what the interface was. It wasn't the fact that we were not getting the right golden path or not understanding developer experience. It was the fact that we were missing a lot out of that platform contract. Self-service, on-demand, extensible just wasn't enough to cut it. The platform contract is incomplete, right? What we think is the initial platform contract is, well, missing a lot. And these are the things that I found were missing. So today, I'm going to talk about the missing parts of a developer platform, the things that you should actually be asking yourself earlier than later. Day 2 updates. What does it mean to update your infrastructure or platform while applications are running? What does it mean to do dependency management of platform and services? We'll talk a little bit more about that. But access control from the platform interface also becomes a really deep discussion, because your platform interface isn't enough to be a platform. You have to make sure it's secure. And finally, local and remote development is still a big question, and it's challenging, because if anybody is going to use a developer platform, you're going to be having to struggle and address some of these challenges. And that's what actually stops the golden path from being truly golden, not the fact that you didn't have a developer platform in the first place. All right, so let's talk about this for a second. Let's talk about day 2. We all think about day 2. And some of us who are not as familiar with the definition often refer to day 2 operations as making platform changes. right? So you've deployed this platform for yourself, and now you have to go in and tell every developer team to either make changes to their infrastructure or otherwise, right? So imagine this scenario. Imagine you've deployed your application and you've got the ability to provision a database, let's say PostgreSQL 13.11. Everything's fantastic. Your developer's like, great, I clicked the template, I provisioned it, I have database. And it's a golden path because it's fairly efficient. Their time to start is very, very low, but then you kind of run into this issue where you realize you have to update the database to 14.9, and well, there is no clear path of how you get the module that you've created on PostgreSQL 14.9 to, well, your application. And this becomes a big question mark. No one really knows what to do in this scenario, so then you start to think, okay, is there a better way to do this? It turns out, at the end of the day, there is not a great one-click upgrade, unless you're maybe using no-code provisioning, but there's really not a fantastic one-click upgrade to do this. Most of the time, you refer to version control. And so version control becomes your escape hatch for doing day 2 operations. And I want to show you a little bit of a sample of why we choose version control, because, well, it's easy. It's a common place for someone to understand. If they need to make the updates, they can. But the reality is they might not. So today I'm going to show you a lot. We're going to be running HCP Boundary, HCP Consul, Vault, Terraform Cloud, and a number of Kubernetes ecosystem, but the patterns here do apply to any tool that you have regardless. So I'll show you what I have right now. So let's take that scenario of upgrading from 13.11 to 14.9 for PostgreSQL. How do I do that? Well, to make it easier on myself, I'm going to do this in an automated way, as much automated way as I can. And right now I'm showing the Argo CD interface, but you can do this with no code provisioning. You can do this with any kind of interface that it goes to Terraform Cloud in a module. What I have is Terraform Cloud Operator running in the background. And what I've done is I've said, okay, I've had a CRD. If you're not familiar with Kubernetes, it's a custom resource definition. I have a CRD that tells me, hey, I have the ability to put in version control a commit that says I'm going to upgrade my module version. This is a compact version of what it looks like. But the idea is that I had version 13.11, and now I've made a commit to say I'll upgrade to 14.9. If you're not familiar with the Terraform Cloud Operator, this is version 2, and version 2 allows you to run a Terraform Cloud workspace and create projects and various things of your choice. So this allows you to do sort of a no-code provisioning approach, but within Kubernetes, and that allows you to, by extension, do any kind of version control. So if you do want to use GitOps, here's an option. So I've already staged the commit already, but I haven't synchronized. One of the important things about day 2 is that you don't always want to make everything continuously deployed. When you're coming to day 2, sometimes you want a pause. You don't want to auto-synchronize for a couple reasons. So in that case, you do want to make sure that if you are doing this, you're going to turn off auto-sync on any kind of GitOps tooling or even Terraform Cloud. You don't want to auto-apply sometimes, right? Especially if it's something as sensitive as a database. So what I'm going to do is I'm going to synchronize that. And you'll notice that it will synchronize. I'm only going to synchronize the out-of-sync one, which is the module. It will synchronize. Yay, it looks green. It's great. It's beautiful. No, actually, it's not quite there yet. So let's take a look at what's going on. If I check out some of my CRDs related to the Terraform Cloud Operator, what I'm going to find is that it's going to give me a status of, okay, did it actually upload the configuration version? What's the run status looking like? So it will take a little bit of time for this change to get applied, and it will get kicked off in Terraform Cloud. If you are familiar with operators in general and you're familiar with secrets getting into Terraform Cloud, how did I get my secrets from Vault? Because obviously, you know, this is a lot going on, but how did I get my secrets from Vault into Terraform Cloud? You can set up dynamic credentials. I have the Vault secrets operator running on the machine, and so it's synchronizing variables that I need from different paths in Vault into Terraform Cloud for me. So it makes it a little bit easier, and I think that it's a nice way to ensure that any credentials that you do have, you're storing and you have safely in Vault, and you can inject them into Terraform Cloud. As I mentioned before, you can use dynamic credentials as well in Terraform Cloud, but if you are doing this kind of option, you have this pattern available to you. All right, so let's check if it's actually running or not. Well, it looks like there's a problem right here. So I said there were 4 live demos, so we'll see how it goes. So it looks like there's a bit of an issue. It looks like the major version is going from 13.11 to 14.9. If you're familiar with most managed databases, you don't always want to allow yourself to do an immediate major version upgrade, right? You want to gate that. If you're using AWS RDS, you're going to get that statement on the apply side, so you're going to get that information very, very slowly. So it's only on apply time, and it will come back from the AWS API and tell you that. What I've done is I've shifted using a precondition very, very early, so it's a faster feedback. So because of this, because you're not allowing people to do an automated upgrade of a major version, what I'm going to do instead is I'm going to break glass and reconcile automation. Breaking glass and reconcile automation is going into what is the big no-no of the infrastructure as code world, which is into your console and then making the upgrade manually. There is actually a reason why you might decide to do this, though. If you have a database admin who's more familiar with this approach and has some specific thoughts around how a database should be upgraded, if you have a number of reasons why your application team may have broken schemas as a result. So if it's something as sensitive as a database upgrade, you have to do with your own discretion. Some people do an auto-apply of changes to a database, an upgrade of minor versions, and there's no problem with it. Other times you have to be more careful and you have to be more sensitive. So turning off all those synchronization points, especially when you have a high level of automation across your environment in your platform, is one way that you can handle day 2 operations. So as this is being upgraded, of course, now we've introduced drift because I've manually broken the glass and now I have to reconcile automation. So I'm going to go back and now I'm going to rerun Terraform, but I'm going to use a refresh-only plan. And the refresh-only plan takes the state and then synchronizes it back, meaning I don't have to go in and figure out, okay, is it 14.9 or not? Since it has drifted, I can bring back that drift and make sure that my Terraform state does not reflect that drift anymore, and I can reapply and nothing happens, right? This common pattern of break glass and reconciling automation is something that we don't talk about often in day 2. It's oftentimes far more nuanced. If you have an incident, for example, and you are debugging manually, and you might have to go in and make those changes, oftentimes you have to bring that back in a separate, as a separate sprint to understand how you make sure that you're not going to have that problem again. So this is applying. I'm not going to go through the whole apply because I think you might be getting the idea. But the reason why we think about this more carefully in general is that if we could switch back to the slides. When you think about day 2, there are a couple reasons that you might want to do this approach. First, version control is something everybody knows now. If you're a developer, if you're a platform engineer these days, we've gotten at least a very good sense of a skill set around version control. And so day 2 operations using version control as the interface, whether it be Terraform or programming language or whatever people are happy with, make sure you have that opportunity for them to do that. If they don't have that, it's very difficult to make day 2 changes. The second thing that I showed was identifying the escape hatch. If you have a console, right, and you're trying to log in, you have to have some way of someone going to make those changes, even if it's uncomfortable. Because as much as we like to say that we're idealists with infrastructure as code, that's not the case. At least the practicality of having to go in and make those manual changes have to be reconciled in some way, shape, or form. And the last bit, which is a tip from a teammate of mine, which I thought was fantastic, is that label your resources by criticality. That way, someone who is looking at the opportunity to break the glass, so to speak, and reconcile everything manually on day 2 understands the blast radius of any changes they make to a specific resource. Labeling by criticality ensures that maybe you as the platform engineer or database admin in this case, who's making the change, you understand how critical this is to your application and the blast radius and dependencies. Speaking of dependencies, this is one we don't talk about. We talk about dependencies in Terraform. We talk about dependencies in applications and dependencies in binaries. But what we don't talk about is the dependency between what you consider a platform and the application. So what do I mean by this? It turns out that when you have an application, it depends on platform resources. Wow. That's why we have a platform. And so if you have an application, it's going to depend on, let's say, a password to access a database. This is a platform dependency. And it turns out we have no good way of handling this. In the golden path, we give them a database password to, give a development team a database password to an application, and everything is fantastic. But then we realize, okay, we changed the password, and now we have to figure out how many other applications are referencing that password. And how do the applications know that they are actually going to need to change and rotate and refresh? This is a really complicated problem to solve, and it gets even worse if you think about other platform components, whether it be networking, whether it be any clusters that you're running on there. It's incredibly complicated. And so how do you express these platform dependencies, and how do you express an application dependency on a platform? And I'm just going to show a specific example, but the pattern applies across any infrastructure or platform component you create. You need some kind of automation component in the middle. As much as we don't like this, you need something that is able to understand the relationship between your platform and your application, and it isn't always your platform interface. It might be an intermediate piece of automation. That's why controllers right now are a very, very popular option for this. So for example, Vault is not necessarily a controller, but there are many options in Vault to understand the dependencies between, let's say, your application and your platform. And so in this pattern, right, with the secret, what we're going to say is, okay, anytime we update the database secret, I'm just going to have Vault take it and signal to any other agents, if you're using Vault Agent, or in my case, Vault Secrets Operator, I'm going to signal to these pieces of automation that something needs to change with the application. So it's a little bit weird, right? Because it's a push model, it's not a pull model, but something in the application needs to know that it needs to refresh, and there's a diff. And this applies to any kind of platform information that you have. If you were familiar with Consul Terraform sync, this is the same thought. We're moving toward event-driven automation in order to express platform dependencies and application dependencies. All right, so let's go to the demo now. We got 1 out of the 4. Okay, so this is a bit nerve-wracking, but we got 1 out of the 4, and so we're going to proceed forward to the second one today. I'm going to show you what it takes to rotate the password and how these dependencies get picked up. This is a more simplistic example in some ways, but it applies to any other kind of automation you need to do across platform and application dependencies. Just to make my life easier, I have a toggle to rotate the password because, I like developing this way. So I have a toggle to rotate the password for me for, let's say, a payments processor application that uses static passwords, right? I think you can say, like, oh, we're going to use API tokens, and anything that accesses anything has dynamic credentials. We're just going to go with the simplest form of credentials, which is I'm statically storing an API token for this API in Vault. That's it. And static passwords are just very difficult to manage sometimes. You don't know if you've changed them. If you're familiar with Vault, there are no leases on them. So if you manually change them, something else has to get picked up, right, with the application or any application that's using that static secret. So right now, you'll notice that I am rotating my password using this toggle because, I don't feel like rotating the password myself. And we do everything as code here as much as possible. I already broke glass once in this demo. I prefer not to break glass again. Okay, so as this is being rotated, I'll show you a little bit of what's happening. All right, so I have the Vault Secrets Operator running on my Kubernetes cluster. So if you're not familiar with the Vault Secrets Operator, it's another way of synchronizing your secrets from Vault into Kubernetes. You have many options. You can do Vault Agent, you could do CSI, container storage interface, but Vault Secrets Operator is one way that you can do it. I really like it because if you have applications that specifically only use Kubernetes secrets, you can just write it to a secret. And just to show you a little bit of the important component of this, let me see if I can pull that up for you to take a look at. There's a really neat way that you can do this rotation. Part of this rotation is going to use the rollout restart target. And what rollout restart target does in the Vault Secrets Operator custom resource for your Vault static secret or Vault PKI secret, etc., this rollout restart target means that it will target a specific deployment stateful set or any pod for that matter that is of this name. And what this will do is anytime the secret changes in Vault, it will roll out and restart. It will do a rollout restart on these deployments. And so I have a dependency on payments processor and payments app, right? Both of these applications and both of these depend on this static secret, which means if I know those dependencies, I can express them to my automation and make sure that rotation is happening automatically or making sure that any dependencies from platform to application are reflecting across both. And so expressing that in version control, harkening back to day 2, is particularly useful. So hopefully by this point, we have rotated our secret. We have. And because I've rotated my secret, I really hope that it's been rotated in Kubernetes. So there's a lot of stuff going on. But usually what you'll see is that there's a synchronization path from the secrets operator, that the secrets operator will read from the static secret in Vault, and then eventually do a restart on the application. It may or may not do it, but what you'll see, actually, it might have already done it. That was fast. Faster than I expect. So you see in the logs, there's a secret synced, which means that the operator picked up the change from the payments processor API token and has now read it out, right, to a Kubernetes secret. And 85 seconds ago, that was really fast. 85 seconds ago, both the deployments restarted, which means that pretty much in just a blink of an eye, those platform dependencies have been handled by this kind of automation, which is incredibly powerful, right? So let's go back and talk a little bit about what we learned as a pattern. First of all, find a source of truth. Vault, in this case, is serving as a source of truth for secrets management. You can say you're using Consul as a source of truth for service catalogs. That's why service catalogs for developer platforms are very, very popular, because service catalogs often serve as a source of truth if you want to do kind of this dependency automation. We're moving toward the automation by event model, right? If there's an event happening, you're going to automate in response. That's why Vault, if you haven't tried out the Vault event system, it is experimental at this time, but definitely give it a try. It's a way for you to understand there's an event that's happening in your system as a dependency and as a part of your platform, and you need to automate the dependency as a result. And finally, use drift as a signal. Drift, in this case, is not a bad thing. Drift is actually a very good thing because it's an event that is happening. Drift signals that there's something happening in your system and you need to do it. All right, we're coming up. We got to move fast. So the last 2 demos, right? The first is access control. It's something we don't really think about, but you need to think about least privilege for platform components. When it comes to platform components, it's a little bit more complicated than saying, like, I have a platform interface. The problem that we run into is that we spend so much time securing service-to-service communication that we forget that we have to have our platform interfacing other services, which is a little bit of a troubling concept, right? Because if your platform interface has admin access to every managed service and every cloud provider that you're trying to read in, someone can compromise it and get the information. So once again, we're going to heavily rely on Vault, but that's not really the point. The pattern is that we're going to use some kind of identity system for us to understand how we're going to access it. And so for the sake of time, I'm going to just speed through this one. I'm using Backstage today just to show a little bit of an example because you want to get into the internals, but if you're using HCP Waypoint, for example, it's going to have a similar approach. And actually, you use this approach quite a bit. Even if you're not necessarily using a developer platform, your CI/CD platforms probably use the same approach. What we're going to do is standardize on a common authentication provider. If you're familiar with Backstage, it has a lot of authentication providers to most VCS systems. So in this case, I'm going to standardize on GitHub. And in this case, I'm taking the user OAuth token that is generated from my authentication provider to GitHub and Backstage, and I'm using that user OAuth token in Vault. So we're going to authenticate to Vault with that GitHub user OAuth token, and with that authentication set up in Vault, I can map to policies on who can access what systems. So for example, if I am in the promotions team, I can't access everything in Terraform Cloud. Instead, I can only maybe access the Terraform Cloud project of the promotions team. And the reason why you might want to do this is that, well, does everybody need write access to everything in Terraform Cloud? Probably not. You want to limit your development team's access to the minimum access they need, so least privilege, right? And so in this case, I'm minting a new token every time that scopes the access a developer has to my managed service. So once I get this Vault token, then I get a Terraform Cloud token, and I can pass that through. If you're familiar with this template, this is for Backstage Scaffolder. I built some custom stuff. So, but if you're doing this in your own organization, you will have this same workflow, right? So if you are familiar with it, you can just say choose, and then Backstage, I'll just say HashiCorp. And the idea is that once I go into GitHub and I authenticate, this is my identity. I don't have to configure new identities in Backstage. I don't have to configure new identities in Vault. I am linking a common authentication provider to both, and now that it's injected that OAuth token, I can take that token to authenticate to Vault, get a Terraform cloud token from Vault, and then use it to create a run, right? A Terraform cloud run. So there's a lot of patterns that you can think about, but if we go back to the slides, let's talk about the patterns for a second. First, centralized identity. Centralize it somewhere, right? You're never going to have it perfect, right? You're going to have identity across many different providers, but if you can, choose one auth provider for all of the things that you're doing. Most of the time, any kind of VCS that you have is a very solid source of truth for it, because a developer needs access to certain parts of the platform. Usually that is something that you'll integrate, especially if you use version control. You'll notice a theme today. And the other thing that you want to think about is that as you centralize identity and you choose a provider, maximize the integrations you have. The reality is if you're doing something like this with Vault, Vault has many integrations but doesn't have everything. So you want to maximize for what you have, and sometimes you will have to have some custom automation to integrate across different systems. So let's say if you have a managed service and it doesn't have a Vault secrets engine, you may have to write your own, or you may have to figure out some automation for that. All right, I'm coming close on time, so here, let's go through this last one. Local or remote development. Local or remote development is the thought about developing locally and deploying remotely. This is incredibly challenging, and as I was discussing with a lot of folks on this and thinking about this myself, I realized we haven't figured this out. And I'm not going to sugarcoat it, we just haven't figured it out. The golden path is that we deploy an application, and an application accesses the database and an upstream service. And things are fine, things are great. We've said, okay, this is awesome. We know that this application is connected to it. But what we didn't really figure out is, well, let's say you have a local version of this application that you're trying because you have a new feature. And you want to integration test it against a remote database and an upstream service that you don't control. How do you do that? There's not a great way to do it. And so actually, we've gotten a little bit closer, I will say that. You can use Boundary to help you do that, right? The idea is that can you spin up some local proxies to these remote endpoints, control authentication to them, and ensure that if you are a developer doing local development, you have the ability to proxy through something, right? And from a security standpoint, you know who's proxying where. And you can access these remote development endpoints. So I'm going to quickly run through this demo, because I see the clock. Like, it's time to get off the stage. But let's do this for a second. So this is Boundary. If you're not familiar with Boundary, Boundary has the ability to proxy to many different remote endpoints. And in this case, I want to access my upstream service, which is that payments processor that we had that static secret for, and we have let's say that database. And I had a new feature that I created locally, and I want to make sure that it works. So I'm going to connect to a remote database and that remote API. Now, a caveat to this. Not all development patterns can do this, right? If your application is read-only, this is probably fine. But if it's got some write capability and you need to be thinking about that, you probably want to be careful. But again, this is a story that is really difficult, but if you have a basic approach to this, it means you cut down on any significant sort of local development, and you can defer to remote endpoints. So I'm going to connect to this database here, and it actually uses credentials brokering from Vault, so it actually issues a new username every time. And I'm going to connect to the payments processor on a different port. So you'll notice different ports, two different ports here, two different sessions. And if I'm a developer, let's hope I can get access to it. If I'm a developer, what I'm going to do is I'm going to go in and I'm going to click on the port. And I'm sorry, everybody, this is a personal pet peeve of mine, but I'm going to show you my credentials. So yeah, everybody, I'm going to warn you, because thanks to Vault, this will get rotated after this. But yes, there are credentials on this stage. So, oh, that's payments, there you go. So this is the payments processor. So I'm going to put in the password, and I'm going to put in the port for that. And yes, I painstakingly have to do this, but we're going back to it. And then I'm going to take the database, and the database has its own port, proxy to local, and then I'm going to put in the password and the username. Now, this seems a bit strange, but I mean, if you have a lot of development teams who are interested in doing a lot of this remote testing, they want faster feedback, right? Because the idea behind this is that, do you want to wait to push to a pipeline, run all of the tests, and make sure it all works? You might not, you might not, right? A lot of development teams may choose that they want something more dynamic. And as it starts up, what I'm going to do is I'm going to send a request and hope it works through the local proxies. So what happens is that if I send that request, and it's hard to tell, I guess, but the idea is that I'm able to do any local testing. If I wanted to run an integration testing suite, I could spin up those 2 local proxies through Boundary, connect to the remote endpoint, and do the local testing that I need as a developer. And I have the ability to audit who's had what sessions or whatever. And if you find that maybe someone's not supposed to be doing something, you have these sessions, right? And your security team can cancel them and audit who's making what connections. So, would you necessarily do this? Does it make it easier? Well, for some folks it does, right? Development is hard to begin with, and well, our definition of local has changed. So if we go back to the slides, one thing you will have to do in your organization as you do this, it doesn't matter if you're doing it with Boundary or something else, define what local means. You could run something on your local machine and it doesn't work remote, right? But what does local really mean to your development teams? That's something you have to think about. Mapping data restrictions is incredibly important. If you have a team that's working, a data science team, for example, they may have more access than maybe a developer does to something. So you have to map those data restrictions and think about that very carefully as you approach this. And the other thing is that balance the cost of testing and the usefulness of the tests, right? A lot of the times when I've talked to folks who are questioning this approach or who are thinking about this approach, the thing is that they don't want the cost of testing environments. They want to do everything as much locally as possible. That's why they have giant mini cubes or giant Kubernetes on local machines. So balance that cost and understand if this is going to be a pattern that you like or is going to work for you. So in summary, the complete platform contract involves all these things. Day 2, dependency management, access control, and local and remote development. And that's when you can call yourself a developer platform. Because without these things, your developers don't really have a golden path still. And it turns out that it's not a golden path. A golden path is a lie because it's really infinite. You just keep repaving it. So when you think about day 0, you're always creating. When you're thinking about day 1, you're running things. When you're thinking about day 2, you're updating everything in your platform. And when you're on the nth day of running your platform, you realize that you have to migrate off of it to something else. And this pattern just continues and continues, whether you're on private cloud, public cloud, managed services, or wherever you're running these days. But we are always paving the infinite golden path. But if you think about all of the things you're missing, you will, generally speaking, have a much more efficient developer experience than if you had just thought about a developer platform to start. If you want to learn more, check out some tutorials. But if you are interested in this demo, I have GitHub code, and it is massive. So everything that you could possibly want, from PKI rotations, Vault Secrets Operator, Terraform Cloud Operate, and more, is in this repository. So check it out. I'd love to hear your feedback. And thank you for listening to me today. And we got 4 out of 4 demos.